Today we'll be talking about bonds. So bonds is something that will be very important for us to understand. And when we talk about the concept of bonds in chemistry, we're really thinking about this chemical bond as a force of attraction between two particles of an element. Okay, so let's say you've got an element like sodium. Let's say you've got another element like chlorine. They may attract each other. If they were to attract each other, that bond, which we wouldn't really draw like that, but this bond is what we're really talking about. Or if you've got hydrogen and chlorine, you might draw it like that. So without caring about accuracy at the moment, we just recognize that if you've got two elements and they somehow attract each other, then that will be what we consider a bond. Okay. Now, there are going to be three main types of bonds. There's going to be the ionic bond, there's going to be the metallic bond, and there's going to be the covalent bond. Okay. 1, 2, 3. So remember, there are three types. And the names of the three types are below: ionic, metallic, and covalent. So when is this the case? Well, we can give you a very simplistic answer. Okay. The metallic bond, as a very simplistic answer, is going to occur between a metal and a non-metal. A metallic bond is going to occur between a metal and a metal. And a covalent bond will occur between a non-metal and a non-metal. It might be helpful to remember what a metal and a non-metal is. Very simplistically, a metal will be anything that is colored now. A non-metal is going to be anything that is colored now. So in very brief terms, you can think of it kind of like having some sort of borderline around here, sort of, all right? And then anything to the left of that border is your metal, and anything to the right and up is a non-metal, as a very rough guide. So we will now be looking at each of these bonds in more particular detail, and we will start with the ionic bond. So looking at an ionic bond, we'll need to consider what an ionic bond is, and we'll take a look at an example of one. So in very brief terms, what's an ionic bond? Ionic bond is a chemical bond that is between, simplistically, without complicating things too much at the moment, a metal and a non-metal. So it's a chemical bond that is between a metal and a non-metal. Let's consider an example. A metal would be sodium. A non-metal would be chlorine. So if you end up with sodium, which we'll represent in red, and chlorine, and they get together, what we will say is that you'll end up forming an ionic bond, not drawn the way I'm drawing it. It's not the way you draw it at all. But you're saying that you'll get some sort of bond between the sodium thing, starting off as an atom, and a chlorine thing, starting off as an atom, and that is going to be an ionic bond. Now, how does this actually form? Well, we said it's between a metal and a non-metal, but further detail would say this is formed by the transfer of electrons. So basically by the metal giving up electrons. So it will give its extra electrons to the non-metal. Okay. So the metal will give its extra electron to the non-metal. What does that mean? That means the metal atom will become, well, a metal ion, which will be positive. The non-metal atom will become a non-metal ion, which is negative. You'll end up at this point having sodium ion and chloride ion. And of course, because there's a positive and a negative charge, they will get a force of attraction. That force of attraction will then be what is called the ionic bond. Let's see how this works. So as you can see, on the left here, we've got sodium. Right now, this is a sodium atom. It's an atom because if you look up sodium in the periodic table, it has 11 protons. It will have around 12 neutrons, which is not shown. And it will also have electrons, shown in blue, arranged in 2, 8, 1. Or if you like, the first shell has 2, that's your 1s. Your second shell has 8, that's your 2s and your 2p. Your third shell has 1, your 3s1. Over on the right, we've got chlorine. This is chlorine because right now it's a chlorine atom. It's an atom because, being chlorine, it's got 17 protons. Depending on which chlorine you've got, it's probably got 18 neutrons. Again, not shown and not important for us. Doesn't matter if it got 18 or 20. It won't make a difference. You'll see why in a moment. And it has 17 electrons. These 17 electrons are arranged in 2, 8, 7. 2 in the first shell, 8 in the second shell, 7 in the third. If you like, this is your 1s2, 2s2, 2p6, 3s2, 3p5. As we commonly say a lot of the time, we say that the atoms want to have either an empty or full outer shell. So you can imagine sodium has this one extra electron that it wants to get rid of. Chlorine wants to have 8. It wants to have 8 electrons in its outer shell. So you can quite clearly see that there's a very beneficial transaction, right? If sodium gives this electron and chlorine accepts it, then sodium is happy, and so is chlorine. Chlorine will also be happy. And so because there's this sort of benefit to both sides, if you like, that's probably likely to happen. And that's what we're going to happen when you talk about ionization. So we would say that the sodium would give up its electron to become the sodium ion and lose the electron, while the chlorine will accept this electron to become a chloride ion. You'll notice that this is the atom, it is uncharged, and it becomes an ion. The chlorine is an atom, it accepts an electron and becomes charged. This is an ion. So watch carefully what happens as it ionizes, all right? The sodium will lose an electron and the chlorine will gain an electron, and therefore they will both become ions, all right? So watch carefully. Loses an electron, this gains an electron, this is now positive, this is now negative, so they will get together. Okay. Now pay close attention. This is no longer a sodium atom. This here on the left is a sodium ion. Before it was a sodium atom. Before. But now, looking at after, we have a sodium ion. Because what do you have now? Well, you still have 11 protons. Nothing has changed there. You still have 12 neutrons, perhaps. Nothing has changed there. But you've lost an electron. So you only have 10 electrons now. Now, because you have 11 protons and 10 electrons, that means you have one more proton than an electron. So now you have a positive 1 charge. If you have a charge, you are not an atom. And that is why you are a sodium ion. Let's now look at the chlorine, which we wouldn't call chlorine anymore. This is what we call a chloride ion. After. Consider what is here. You have 17 protons, still. Nothing's changed in the nucleus. You'll probably still have 18 neutrons, or whatever you started with, you still have that. But if you count up the number of electrons here, you now have 18 electrons. And if you compare the number of protons against the number of electrons, they are no longer equal. The number of electrons is 18. The number of protons is 17. So you have one more electron than you have protons. That will then result in a -1 charge. So that's why we say it's Cl-. And a Cl- is a chloride ion. That's why this is an Na+, which is a sodium ion. You should be aware that a positive charge and a negative charge attract. And as a result of that, this attraction between them is the ionic bond. Sodium and chlorine is just one example out of many. Let's show you a few more examples, but they all operate the same way. So let's take a look at, say, lithium and chlorine. Lithium is number 3 on the periodic table. You've got 3 electrons, 1s2, 2s1. Chlorine, we've already talked about. You can see that lithium wants to lose 1 because getting 7 is quite hard. Chlorine wants to get 1. So what will happen is it will lose 1, it will give it across, chlorine will gain 1, this becomes positive, this becomes negative, and then they will join together again. Sodium and fluorine, a very similar thing will happen. Sodium will lose 1 because it wants to, fluorine will gain 1 because it wants 1, this will become positive, this will become negative, and they will attract. Of course, these are examples with group 1 and group 7. You're not limited to group 1 and 7. And we can take a look at magnesium and oxygen. So over here, magnesium, you've got 2, 8, 2, with a total of 12 protons and 12 electrons. Now, it doesn't want 12 because that means you've got a shell on the outside that's not empty or full. So its options are to lose 2 or gain 6. Losing 2 is probably easier. So that's what usually happens, or basically always happens. Oxygen can gain 2. So this is a good example of, well, just if you give away 2 and oxygen wants 2, that's fine. 1 magnesium and 1 oxygen, we can simply get it to oxidize. Magnesium loses 2 electrons to become 2+. Oxygen gains 2 electrons to become 2-. This is now your oxide ion. Remember, IDE, anytime you have a nonmetal becoming an ion as an element, it becomes IDE. And this is your magnesium ion. Just a reminder, we call them ions because they are charged. They are charged because the number of protons no longer equals the number of electrons. just quickly noting here, you've got 12 protons in the nucleus, but only 10 electrons outside. So overall, this is positive, this is negative. So overall, 2+. For the oxide, you've got 8 protons, but you've got 10 electrons. This is positive, this is negative. So overall, 2-. That's why we write Mg2+ and O2-, representing ions. They will form an ionic bond between them. We can make things a little bit more complicated with something like magnesium chloride. It's the same idea, but as we can see, magnesium has 2 extra electrons that it wants to get rid of. Chlorine only has 1 empty spot. If you want to give 2 electrons to chlorine, it won't take them. It can't take them. It doesn't want an extra one. It doesn't want an extra one after it's taken one. So you will only take 1. So the solution is quite simple. You just get 2 chlorines to match up with 1 magnesium. And that's okay because you've got 2 extra and you want 1. And this one also wants 1. So the magnesium will simply give 1 to each. It no longer needs to give both electrons to the same one, like it did with oxygen. That's one way to do it. But another way to do it is to go, okay, this one, maybe you go here, this one, maybe you go there, or the other way around. It doesn't matter. But the point is, once that happens, magnesium is happy again, and both chlorine are happy again. So take a look. The magnesium will become 2+ because it's got 12 protons and 10 electrons. Each chlorine has 17 protons, and they both have 18 electrons. Of course, recognizing this negative, recognizing this is positive, you can work out the overall charges for each one. This, of course, is -1, +2, -1, which is why we write Cl- and Cl- and Mg2+. But because I have 2 chloride ions with 1 magnesium ion, the overall charge is still uncharged. So to be clear, the magnesium ion is charged. The chloride ion is charged. But magnesium chloride, MgCl2, is not charged. The compound is not charged, even though it is made up of charged ions or charged particles. Okay. That's why when you're trying to work out your ionic formulas, you need to know your valencies and you need to balance them. Because overall, the substance is uncharged, even if the things that make them up are charged. Let's take a look at calcium chloride. Same sort of idea, just you've got something with a bigger shell in the middle this time. 1 electron each, you form an ionic bond. That is your ionic bond. We'll now just expand a little bit more on what we said with regards to ionic bonds and what forms between them. More accurately, an ionic bond forms not just between a metal and a non-metal, but more accurately, it forms between a positively charged particle, which we call a cation, and a negatively charged particle, which we call an anion. Basically between a positive ion and a negative ion. Now, if you start with a single atom and it just gains or loses electrons, then usually to become a positive ion, a cation, it's the metals because they want to lose electrons. They have an extra one. That's not always the case. And an exception that you come across very often is hydrogen. You should be aware that hydrogen can form an H+ ion, even though we would think of hydrogen as a non-metal. Hydrogen is a little bit weird in the sense that it can also form an H- ion, but usually it's an H+ ion. Anions are usually non-metals. Okay. But where you need to also consider is the idea of polyatomic ions. Polyatomic ions are still ions. So they also form ionic bonds. So we can, for example, take something like NH4+, ammonium ion. That will easily form an ionic bond with Cl, chloride. So you'll get NH4Cl. If I still use ammonium, I can say, all right, we could have ammonium, NH4+ with nitrate, NO3-. The key thing to note is that you've got a positive on the ammonium and a negative on the nitrate. And so when you put these together, then of course it's just NH4, NO3. If we were to change things up and make them not 1-to-1, so we've got ammonium, and let's say phosphate, which is 3-, then that means I'm going to need 3 of these to deal with one of those. And we would just write this as NH4, 3PO4. Importantly, you need to think of these as ions. It's not, even though nitrogen and hydrogen are non-metals, this is a positive, right? Treat the whole thing as an ion, and they still form ionic bonds. Just keep in mind, it's the electrostatic force of attraction between the cation, whatever that is, and the anion, whatever that is. That attraction between them is what we call the ionic bond.